All right, let's do it. Because I want to give you guys enough time. I'm going to do 3 problems with you, and then the rest is up to you for the notes. All right, the rest is on you for practice. All right, so example 6 we left off with yesterday. We have a rhombus with whatever the heck those are attached to them, right? Find the area of the entire diagram. Leave your answer in terms of pi. All righty, I can do that. So here we go. Full area. We know it's going to be rhombus plus what's attached to the rhombus. Talk to me. 3. Eva, talk to me. What's attached to that rhombus? Which makes how many full ones? 1.5. So rhombus plus 1.5 circles. That's what I'm going to find the area of. Rhombus formula. What do you got for me? Look it up. Look back if you need to. 17. Area of a rhombus.
Is it 1/2 D1 times D?
What's D?
Diameter.
Oh my.
Sorry, not diameter. Diagonal. Sorry.
Thank you. Diagonal lengths plus area of a circle. 13. Area of a circle.
Pi r squared.
1/2 and then times pi r squared. Everyone all right where the 1/2's coming from? You see where that? I got 1.5 full circles. All right, you guys are helping me out filling in for D1, D2, and R. You got it. Whoever's up next, you got it easy. What are the diagonal lengths here? You got it easy here. 11.
24.
24 times 10 plus. All right, we got some work to do now for our radius, don't we? We got some work to do. We went over properties of a rhombus yesterday. No, 2 days ago. Sorry. Does everyone see what I'm going to need to find the radius? I'm going to need one of these right here. This is a what? Not a radius, but diameter. I'll cut it in half. I need your help finding that, though, before I can cut it in half. What can I do with the 24 and the 10 and the rhombus? Help me out. Plans, 24. Diagonal's perpendicular. That's where your right triangle comes from. Keep talking.
And then you have triangles also bisect each other.
Darn right they do. So what do I have here?
So on that top triangle,
Yep.
you have a 12 and a 5.
Perfect. Everyone good? Where Mahmoud's coming from? Diagonals bisect each other. 12 and 5. Now we're doing, we didn't finish it. What are we doing to find the diameter? Go. Let's go. Machines. And actually, I'm not satisfied yet. Where's the 12 and the 5 going here? 11. Where's the 12 and the 5 going in Pythag? Good. Whew. I'll ask somebody in a second, what's the length of that diameter? Is anybody's got to be aware of here? Left up front? No? A little popping? How did this magically just appear up here? I'm not going to open it, but nobody's taking credit for it. Was this left on a desk before? Because it hasn't been up here all day. It wasn't even up here last period when I taught.
I said you open it.
No, absolutely not. No way. It's not mine. Not opening that. What'd you get for the diameter length? 3? 13. So now when I plug it in, don't plug in 13. We'll plug in 6.5. Your battle is almost won. What were the directions again? Terms of pi. So that means what has to be in my answer? Pi, meaning what button are you not touching on your calculator? The pi button. But we can do everything else. So 1/2 times 24 times the 10. Area of the rhombus, $1.20. Plus, the pi is going to be here, but I could still do 1/2 times 6.5 squared. What do we got? 63.375? That's what I get with 1.5 times 6.5 squared. Yeah.
Would you be able to do 3 and then parentheses 1/2 pi 6.5 squared?
Yes. Because if you do 3 times 1/2, it's 1.5. So yeah, it still works. Yep. All right, now I have a question for you, honors kids. Done? Or can I combine those two? Done or combined? You got your calculators with you? Because we can figure this out pretty easily if I'm allowed to combine or not. Everyone right now, type that in your calculator and find out what decimal it is. I'll do it with you. Let's see if we can combine them or not. 120 plus 63.375 pi. So there's my answer. If you want to combine them, what would it be? Let's see. 120 plus 63.375, right? It would be that with a pi. Everyone agrees if I could combine them with a pi? Well, let's see. Times it by pi. Can I combine them? They're not the same answer. So what I have right here is in terms of pi. You cannot combine them. And if that didn't make sense, let me do it a different way. Pretend that pi is an x. Are you going to combine that? Absolutely not. Right? You would not go any further if that was an x and try to combine them. So we're not going any further when it's a pi. You're done. We're done. No units, so I'm going to leave it naked. All good? And here we go. Actually, you know what? I'm going to leave 7 for you to do on your own later in a minute here. Okay, I'm going to leave that for you to do on your minute. Let's go to today's notes, and I'll do the first one with you. So you guys, last night at homework, you've had some exposure with mushing, smushing two figures together and finding the area, right? That's what we just did with the rhombus and the circles. You've had experience with how to find shaded regions. Last thing I got to expose you to, what if it's just a figure? I have no idea what it is. I have no area formula for it. Look at that. Look at 1A. It's got 5 sides. It's a pentagon. I don't have an area formula for that. But what can we do? We can break it up into figures we do have formulas for. Is there anything, extra lines you can draw in here so you can break this figure up into something that we do have formulas for? Don't add on anything. Use this figure right here. Can you draw anything inside that it's like, oh, that's going to be this, this, this? I have formulas for that. Hello, Tammy.
You could draw an altitude.
Okay, which one? You want to go a vertical or horizontal?
Vertical.
Okay, so here's what Tammy's saying. Draw that in right there. And now what do I have on the left? Left. Your other left.
Rectangle.
Rectangle. And on the right? Trapezoid. Did anybody want to do this instead? Yeah, you can do that. Now you got a rectangle on the bottom, trapezoid on top. Or maybe some of you get nervous here and maybe draw in another line. And now you got a rectangle, rectangle, triangle. You can do that too. All right, I'll go with Tammy's first advice, which is let's draw this in. So the area is going to be rectangle plus trapezoid. Length times width plus, all right, who's on the hook? Who's got the trapezoid formula? Yeah, you do. 11, you're on fire today, Paul. Trapezoid formula?
1/2.
Yeah, it is.
B1 plus B2.
Come on, you're not giving it enough love.
Oh, height.
Height. Yep. All right, length times width. I think it's already there, right? 8 times 12. For mine, anyway. I'm doing it different. Okay, that's fine. Do it differently. You won't have the same calculation, but you'll have the same answer, I bet. 1/2. What are the bases on this one? 5 and 12? And how about the height? Height? I thought I heard a 17. Yep, that's 8. So the height here, 7. Good job. And again, I don't care how you did it. We should still all end up with 155.5 inches squared. And I don't want to knock a third way this could have been done. I see a lot of this too. To make it into a rectangle and then take out that triangle. That's fine. That's fine. I'm not going to knock it. Still good. All right, here's the deal today. It went pretty well in period 2, surprisingly. You're going to go back to example 7. Get that done. Hey, I got it done. Can you check my answer? And then you're going to go finish the notes from today. I'm going to try it. Don't let it backfire on me, and don't let me regret it. But if you want to move around and work with other people, that's fine. You just know my deal about working on with other people and what should be done and what should not be spoken about. All right, so if you want to work with other people, move around, group up. But hey, call me over when you guys are done with a problem before you move on to the next. All right, get it done. Here we go. Should have enough time to start the HW.